Alright guys, today we're going to look at another method of multiplying polynomials. It's probably one of the more common methods that people will use, but in my opinion it's kind of the most complicated and probably the easiest one to make some mistakes on, and that is the distributive method, which is pretty easy to tell by the name. It's basically applying the distributive property in terms of polynomials instead of just single values being multiplied into a set of parentheses. But I do want to go ahead and show you what that looks like. Personally, I recommend the table method, which you can find a video here on the channel on how to use that, unless you're multiplying just two binomials, and then I will use the FOIL method for doing that. So looking at what I've got here, my example, I've got x plus 3, which is going to be multiplied by 3x cubed minus 2x squared plus x plus 1. The idea behind the distributive method works basically the same way it would work if this was just like 3 times this polynomial. You're going to multiply each value by each value in the parentheses. And so basically I'm going to take this x and I'm going to multiply it by every single value in this other polynomial, and then I'm going to take this 3 and do the exact same thing, and then get my results, combine my like terms, and move on. And so I want to kind of show you what that looks like. So starting with the x times 3x cubed is 3x to the 4th. X times negative 2x squared is negative 2x cubed. X times x is x squared. And then x times 1 is x. And then 3 times 3x cubed is 9x cubed. 3 times negative 2x squared is negative 6x squared. 3 times x is 3x. And then 3 times 1 is 3. And again, I have people ask me why I don't recommend this method in most cases, and you're kind of looking at it. There's just a lot of stuff going on here, a lot to look at, and it's not as easily organized as the table method or other methods. And so looking at what I've got from this point, I have this very long polynomial that I need to go through and combine all the like terms that I can before I have my final response. And so I like to start with my highest exponent. So I have 3x to the 4th, and then I'm going to go ahead and mark that off just so I know I've used it. And then looking, I've got plus 9x to the 3rd. And then I have, oh, I missed one. And see, this is exactly what I'm talking about with this distributive method. It's so easy to miss and make a mistake on one. And so I have a 9x to the 3rd minus 2x to the 3rd, which is 7x to the 3rd. And so that takes care of that. For my x squareds, I have an x squared, and I have minus 6x squared, so that becomes minus 5x squared. I'll go ahead and mark those off. Then I've got x plus 3x is 4x, and then finally plus 3. And so the result of multiplying these two polynomials together is going to be 3x to the 4th plus 7x cubed minus 5x squared plus 4x plus 3.